Well, good evening, students. This is Mr. Picard, and we're going to get busy here on 3132 solving systems of equations. Okay, in this problem with Travis here, the initial cost for Travis and his band to record their first CD was $1,500. Each CD will cost $4 to produce on top of the $1,500. If they sell their CDs for $10 each, how many must they sell before they make a profit? Okay. So first of all, find the equation for the cost of the CDs. Well, let's say each CD sold or each CD made, we'll say number of CDs is going to equal X. That's our variable. The equation for cost then, we'll say Y is the total cost. Well, each CD made is going to cost $4, so that's 4X, 4 times X. And it was initial fee of $1,500. So the cost to make CDs is Y equals 4X plus 1,500. Now, profit. They sell their CDs for $10 each. So, well, how much money will they make? Well, it'd be $6 per CD, plus you got to work with the 1,500. But just to make it easy, let's say this. They sell them for 10 bucks each. So they make 10X at 10 times X. Now, if we were to graph these, this is the cost CD, this is the income CD. Here's kind of what it looks like. Okay. Okay. This one right here, I'll put it in red, is what it costs to make CDs. And this one in blue, we'll leave it blue, is their profit function. And you can see they intersect at this point right here. That point right there where they intersect, I'd call that the break-even point. So basically, if they sell 250 CDs, it's going to cost them $2,500 to make those CDs, but they're also going to make $2,500. So anything after 250 CDs sold, that's where they're going to start making money. They're going to make it a profit of $6 on every CD after that, but they got to sell 250 to break even. Notice that's where the two lines intersect, point of intersection. We're going to be solving systems, and that's what we're going to deal with, points of intersection. Two or more equations with the same variable, 3 ways to solve these systems of equations. We're going to get into this. First of all, graphing. You can graph two linear equations and find the point where they intersect, right here. This green point is a point of intersection. That's how you solve a system. Other than graphing, we have substitution. And the last one, my favorite, elimination. So we're going to learn how to graph, use substitution, and use elimination today. Now, when you're graphing these, a couple different things can happen. Number one, you could have two different lines and they intersect at one point like this. That one point is your one solution. This is called consistent independent. So you could write that up here if you wanted to, consistent independent. You might have this also, consistent dependent, okay? It's basically the two lines are the exact same line. So you have a line and then another line on top of it. Well, where do they intersect? Well, they intersect in infinitely many points. So they have infinitely many solutions. And that would be the second type of a solution. And then you have this, parallel lines, but they don't intersect. This is inconsistent, meaning this, they don't intersect, so they have no solutions. So you have a choice. There's either going to be one solution, infinitely many solutions that are the same line, or just two parallel lines where you have no solution. Okay. So we're going to graph this first one here. It says solve the system of equations by graphing. Let's bring this over here, make it a little bit bigger. Now these are both in standard form, so I'm just going to use my x and y intercepts. So 2x plus y equals 5. Well, first of all, if you plug in 0 for y, you'd get 2x equals 5, or x equals 2.5. So there's my x-intercept right there. Plug in 0 for x, and you get y equals 5. So there's my y-intercept. You can also use the cover-up method, I guess you could say. So I got those 2 points. Let's throw a line through them. Well, I'm pretty close right there. And we have this other line here, x minus y equals 1. So plugging in 0 for y, first of all, I get x equals 1. Well, there's 1. Plugging in 0 in for x, I get negative y equals 1, or y equals negative 1. There's my y-intercept. Now you can see I'm going up 1 and over 1 to get to this point, so I can generate more points for this line. And throwing in a line here. There we go. Where do they intersect? Right there. The coordinates to that point are 1, 2, 1. 2, 1 is the point of intersection, so that's my solution. Solution is the point where the two lines intersect. Okay, here's another one. Graphing this bad boy. Well, x and y intercepts are going to be tough for this one. If you look at this top equation, 5x plus 4y equals 7. So what I'm going to do with it is this. I'm going to solve it for y and put it in slope intercept form. So let's take 5x plus 4y equals 7. First of all, subtracting 5x from both sides. 4y equals negative 5x plus 7. We're not done yet. We're going to have to divide everything by 4. And I get y equals negative 5/4 x plus 1.75 roughly. Well, exactly, actually. So I got my line here, and I got my line here. And the thing I notice is they both have the same slope. So these lines are going to be parallel. But they do have different y-intercepts. So they're not going to be the same line. So it's not going to be infinitely many solutions. It's going to be no solution. But let's graph them anyway. I'll graph this first one over here we'll graph that one in blue. Up 4, and then down 1, 2, 3, 4, 5, over 1, 2, 3, 4, right there. Throwing a line. And there's my line. Graph this bottom one here in red. The one we solved for y, put it in slope intercept form. 1.75 is right about there. Down 1, 2, 3, 4, 5, over 1, 2, 3, 4, right there, and right there. Okay, let me see if I can line it up. There we go. You can see that the two lines are parallel. They have the same slope. They don't have the same y-intercept, so they're not the same line. This particular solution is going to be no solution. No solution. There's no point where the two intersect. Okay. Okay, steps for substitution. Now we're going to solve them algebraically. We'll get into elimination tomorrow in school. I'll finish up the notes, but solving systems of equation by using a substitution here. So I'm going to bring this over, make it a little bit bigger. 4 steps to substitution. Number 1, get one of the variables by itself in one of the equations. In other words, solve for one of the variables. Okay, I can see here that this equation is solved for y. I'm going to put parentheses around what it's equal to, and that's 1/2 x minus 18. And the reason is this. Step 2. Let's see if we can get this in here. Okay. Substitute this equation into the new equation into the other equation in place of that variable. What that means is this. We're going to take this 1/2 x minus 18, that's what y is equal to here, and plug it in for y in the other equation. So I'm going to rewrite the second equation here with the same things except for y. Y is going to become this up here, what y is actually equal to. So x plus 2 times y, but now I'm saying y is equal to 1/2 x minus 18. Equals, don't forget this part over here, 18. Okay, so we did that. And number 3 here, solve for the remaining variable. So if you notice, I have an x here and an x here. I don't have any more y's, so I can solve this equation for x. And I end up with x plus, well, 1/2 times 2 is 1, so that's x. 2 times that is negative 36 equals 18. So 2x minus 36 equals 18. And now we got to get into work a little bit here. Subtracting 36, actually adding 36 to both sides. I'm going to get 2x equals 54. And finally, just dividing by 2, x equals 27. So right here, I'm going to write solution. I know my x value is 27. How do we find the y value? Well, let's see if I can get this down here somewhere. Plug this new value into either one of the 2 original equations and solve for the remaining variable. Well, I know this, x equals 27. So I can take my original function over here and plug 27 in for one of the x's. I can either plug it in for this x or this x. And I'm going to use this one, y equals 1/2 x minus 18. I'm going to plug the 27 in right here. It's easier because it's already solved for y. I could plug it into the other equation for x, but let's just go with this. 1/2 times 27 minus 18. And that is going to give me 13.5 minus 18. 13.5 minus 18, we get y equals negative 4.5. So right up here, negative 4.5. There's our solution. The point where these 2 lines intersect is going to be the point 27, negative 4.5. Okay. Let's try this one. Okay, I'll set this problem up for you and then we'll be done. Matthew stopped for gasoline twice on a long car trip. The price of gasoline at the first station is $2.56. At the second station, the price was $2.65. Matthew bought a total of 36 gallons. That's a key number right there. And spent a total of $94. So the 2 variables we're dealing with here is this. How much gas did he buy at the first station? How much gas did he buy at the second station? So how many gallons of gasoline did Matthew buy at the first station? Let's say this. Number of gallons at first station is going to be X. And number of gallons at second station is going to be Y. So here it is. There's 36.1 gallons altogether. So if I take the number of gallons at the first station, the number of gallons at the second station, and add them together, X plus Y, I should get 36.1. Now, this $94, where does that come in? Well, it's $2.56 per gallon at the first station. So I'm going to say 2.56X plus it's $2.65 at the second station, 2.65Y. If I take how much it costs per gallon and multiply by the number of gallons for the first station and do the same thing for the second station, when I add it all together, I should get $94. Okay, so I'm going to let you guys solve this one. And here's the deal. At the first station, you should get roughly 18.54. And the second station, you should get 17.56. So I'll let you guys try that. You're going to use elimination. I'll give you a hint. Multiply this equation right here through by negative 2.56. Oh, well, you guys do it whichever way you want. But that's the answer. I will talk to you later. Bye. Bye.